I work on data visualization and how to treat data when it's uncertain, especially from a design perspective. I work on design of experiments, how to look at time series. The look at is an important part. So this is the agenda that we're going to look at. So, the hypothesis tests, normal distribution. The second part of that is the difference in difference. And the third part is how do we compare two different time signals. So there are two fundamental hypotheses, terminologies here. One is called the H0 and the H1. H0 stands for the null hypothesis and H1 stands for the alternate hypothesis. So what does it mean? So in our context, a null hypothesis could be something like increasing the frequency of the ad is going to increase the return on the ROAS. Whereas the H1 is no, it does not. So these are the two hypotheses that we will. So towards the end of the experiment, what you will do is you will either accept the H0 or the H1 or reject the H0 or the H1. What is the level of confidence? There is usually a lower bound and upper bound that we associate these metrics with. So the point is, do I accept 0.05 variation from the normal status, or that itself is too much for me? If it's too much, then you say 5% and 95%. 5% is if it is going to be less than 5%, it is significant. If it's greater than 95%, it's going to be significant. That's going to be the tails of the two Gaussian distributions that we have. So you see this bell curve, which is the Gaussian distribution. And this axis out here is the z-axis. And these shaded regions are the probability content that we are interested in, right? Like the value of z, here it is 1.96. That makes this content, this 0.025 is the z alpha. And then this is my z alpha, which is 1.65. So 0.4 is hovering somewhere here. So if it's greater than 1.65, then I would reject the null hypothesis, right? So in this case, I failed to reject the null hypothesis. Just in case if it was greater than 0.1, like let's say the probability of z greater than some value was greater than 0.1, then your p is not significant. So these are the ways in which we make sense out of p, the alpha value, and the z alpha stuff.
And the question is whether the given data set is statistically significant at 90% confidence level. We've got 15 correct answers. Let's see the leaderboard. When we design a geotest, we go through a process of market selection, and we use a package called GeoLift package, which is open source package from Facebook. For arriving at this step, we do some pre-processing and some exploratory data analysis. What you're seeing now in this template is the typical result that we get from running the market selection function in the GeoLift package. So you will get different IDs here, which is market selection output ID, and each row here has a group of geos. These are all DMA IDs, and you see that in each of the market selection ID, you have 5 DMA IDs that have been simulated as test geos, and different metrics from simulating them to be a test geo. We'll talk about specifically one metric, which is the absolute lift metric, which is one of the important indicators of for us to know how well a specific set of geos will work when we use them to test on, right? When we say absolute lift here, it means lift when there is no real treatment that's going on there, right? So we need to make sure this is as close to zero as possible.